Our next speaker is Dr. H Wright, and Haley is a research fellow in the university here, and she has PhD in psychology, and her interest is studying cognition and sleep.
So thank you, George, for the introduction. My name's Hayley. For the past 18 months, I've been working with Michelle and Franco on a project looking at the relationship between sleep and cognitive function in adults over the age of 50. And I'd like to thank Michelle and Franco for inviting me here today to talk to you about the different ways that we can measure sleep and cognition. So first of all, you might be wondering exactly what we mean by cognition or cognitive function. And I'll be using these terms interchangeably through the talk, just to describe a group of mental processes that can involve functions like memory, forward planning, thinking and reasoning, and language, attention, all sorts of things. Okay. So why do we want to measure sleep and cognition? First of all, we might just want to know, for our own information, if we're just curious about how well we sleep, for example, we might download a sleep app for our iPhones, we might take an IQ test, and this could then help us to understand changes across the life course that might affect sleep and cognitive function, such as pregnancy, retirement, or menopause. These measures can also help healthcare professionals to make a diagnosis if there are any particular problems with our sleep or cognition, such as sleep disorders like insomnia or memory impairments. And this can then lead to more appropriate treatments being offered. And lastly, there are a variety of ways we can measure sleep and cognitive function to answer specific research questions. And that's what I'm going to be focusing on today. So what exactly will we be talking about? So cognition can be divided up, as I've said, into many different processes, some of them being memory, attention, language, and perception. And sleep, through sleep we can measure certain functions such as quantity, which is how long we sleep, quality, which is how well we sleep, and we can also measure certain problem behaviours or disruptive behaviours such as snoring and sleepwalking. So there are objective and subjective measures of both of these. So for example, we can measure cognitive function through lab experiments where we can use computers to test reaction times. We can measure brain function through things like EEG or fMRI. Or we can use simple pen and paper tests, which would be like a test that you take at school. Likewise for sleep, we can measure this objectively through polysomnography, which I'll talk about a little bit more later. There's actigraphy, which is like wearing a wristwatch during your when you go to bed, and it tracks your sleep activity and movement through the night. And again, we can measure sleep through self-report, so basically asking people how well they sleep or how long they sleep. So this is an example of EEG. Here we would measure cognitive function through brain waves, which are measured through the skull using these sensors that are arranged around the scalp. The graph at the bottom just shows 1 second's worth of EEG data. So you can imagine it's quite a complicated process after you've done an hour-long experiment. This is an example of polysomnography. So while you're asleep, you would have lots of sensors attached at different areas of the body, measuring things such as airflow through the nose, eye movements and brain activity, the amount of effort it takes to breathe, and the amount of oxygen flowing through the blood. And again, at the bottom, there's an example of data output from a polysomnogram, which again you can see is quite complicated, and hopefully this should give you some idea of why it's quite difficult to use these measures in large-scale research studies where we're collecting data from tens of thousands of people. It would become quite costly and also quite time-consuming. So in studies such as the one that I've been involved in, we tend to use pen and paper tests for cognitive function and self-report measures of sleep. So that's what I'm going to be focusing on today. So we can measure sleep subjectively through questionnaires and interviews. And the benefits of this is collecting a large amount of data in a relatively short space of time, collecting on measures such as quantity and quality. But these might be subject to self-report bias and inaccuracies. So for sleep quantity, we'd simply ask, how many hours a night do you spend asleep? For sleep quality, we would typically ask questions such as, how frequently do you have difficulty falling asleep, for example. These would be scored on a progressive scale of frequency, where a higher score indicates a higher level of disturbance. And again, we would also ask people to give a general rating of their own sleep quality, and where a higher score, again, indicates a higher level of disturbance. So moving on to cognitive function, we typically divide this into two broad categories of memory and non-memory or executive function. So memory can be measured using different types of tests, typically learning and recall of word lists, and prospective memory, which is sometimes called remembering to remember. And this is where you would be given a specific task to perform at a later date, and you would have to remember to do that task. Orientation would be knowledge of orientation in time and space. So, for example, knowing the date and knowing where you are in terms of geographical location. Similarly, for executive function, we can have specific tests of attention, language, including comprehension, and visuospatial perception. But today I'm going to be focusing on word lists and attention. And as George said, there would be some audience participation, so this is it. Please don't feel obliged. If you really don't want to do it, it's fine, but it is supposed to just be a bit of fun. So if you want to take part, please do so. So we'll start with a memory test. I'm going to read you out a list of words. Okay, there'll be a list of 10 words. I want you to listen to me read them out, wait until I've finished, no cheating, and then take a clean piece of paper from the pads that you should have in your conference packs, and then I'm going to ask you to write down as many as you can remember, and I'll give you 1 minute to do that. Okay, when you've finished, after the minute is up, I want you to fold the paper in half and put it on the floor. Okay, so if everybody's ready, I'll read out the list. I can only read this once, so listen very carefully. If you miss one of the words, don't put your hand up or anything, just carry on. Here we go. Water, church, doctor, palace, fire, garden, sea, village, baby, table. Okay, 1 minute if you write down as many as you can remember. And stop. Thank you very much. So now we're going to do a test of attention. So in your packs, you should have a piece of paper that says, do not turn this over until instructed, or something like that, and it's got lots of letters printed on the back. This is something like what you're going to see. You need to start at the top left and work across the page from left to right, top to bottom, as if you were reading a book. Then go along the letters, crossing out all the P's and W's. And then when I say time up, underline the last letter that you reach in your search, wherever you are in the grid. Okay, so when I say go, you can turn your paper over and start crossing. Hold on. And go. Time up. If you underline the last letter that you reached in your search. Thank you very much. So just to give a recap of what we've done. So firstly, we did a memory test where I asked you to simply recall words that I read out of a list. We've done an attention test where I asked you to find the target letters in a grid amongst a lot of distractors. And we also did a prospective memory test, which you may or may not be aware of. Did everybody remember to fold the paper and put it on the floor? Can we have a show of hands if you did? Okay, that's good. So that's an example of a prospective memory task where you're given an instruction at the start and then asked to remember to do that again at a later time. So now we're going to have a surprise memory test. So if you find a clean piece of paper in the conference pack, and now again I'd like you to write down as many words as you can from that first list that I read out to you. Okay, so you have 1 minute and go. Stop. Okay, if you want to score how well you've done, I can read the words out again and you can kind of tick the ones that you got right. And then you should end up with 2 scores, one for the first list and one for the second list. Okay, so the words that I read out to you, you don't get any bonus points for making up your own words, right? Just so you know. Okay, these are the words that you may or may not have. Water, church, doctor, palace, fire, garden, sea, village, baby, and table. I know that people like to know how well they've done in comparison to other people. And we have the scores from our ELSA data set. So these are typical of people aged 50 to 89. Now, I appreciate that some of you here might not be in that age bracket, but this is just for an example to show you some typical scores for that age range. So for the immediate recall task, does anybody want to hazard a guess at how many out of 10 a typical male would remember?
I'm a typical male. I scored 6.
You scored 6. Let's have a look. And you are typical. How about females? Does anybody think, would they be better? 8? 6. So we're level pegging at this stage. And what about delayed recall? So after the interference of the attention task. 5? Any advances on 5? 7? 6? Let's have a look. 4 for the males. Okay. And what about females? Do you think they would be better, worse, same? 7? Anyone else? 6? 5. So a little bit better than the males, but not much. Okay, now the attention test. If you want to have a go at scoring it, you can. I know it might be quite complicated. First of all, we take measures of how many letters are searched in total. So that's the letter that you reach and you underline. There's 30 letters in a row, if that helps. So, for example, if you get down 10 lines, that will be 300 letters that you've searched. So if you've managed to kind of add them up, an estimate will do. How many letters do you think an average male would search in 1 minute? Bearing in mind there's 780 letters in the grid. People typically get to about a third of the way down. How many do you think an average male might search? 280. 280? Any advance on 280? 308. 308? It's very specific. 400? 288 in a minute. What about females? Do you think they would search more and hence be quicker? Or do you think they would search less and be slower? More? Yep, 315. Okay, so then we take measures of accuracy as well, which is how many target letters you manage to cross out. So if you want to quickly total those up, how many P's and W's you managed to cross out? How many? Okay. So there's 65 in total in the whole grid. Bearing in mind people tend not to get to the bottom. It's very, very rare that people would get to the bottom of this in a minute. How many do you think is an average number for males to have crossed out? 20? 18. What about females? Do you think would be better? How many? 22. Oh, 20. Okay, so this is just an average set of scores for a population that we've been studying. It is looking slightly biased towards the females. I didn't do that on purpose. These are just the tasks that it's easy to administer with such a large group of people. But males do outperform females on certain tasks, you'd be pleased to know, such as numeracy or mental arithmetic and verbal fluency. So, for example, if we ask people to name as many animals as they can in 1 minute, the males tend to perform a little bit better. So you might be thinking that these tests are a little bit abstract, and why do we use these in research? What do they mean? So we can use the scores from these kinds of tests to make inferences about everyday abilities. So, for example, the letter cancellation task that you've just done would give us a measure of visual scanning, speed of processing, target detection, which could be useful for things like finding a knife amongst forks in a cutlery drawer, or scanning the road for traffic or hazards, which could be particularly difficult with people with dementia, for example. The prospective memory test, which is remembering to remember, can give us an idea about whether people would maybe remember to switch off appliances after they've used them, or to remember to lock the front door after they leave the house, and also meeting friends, keeping to appointments, and remembering to take medications on time. So that's all. Thank you very much for listening, and thank you for taking part in the tests.